Hey, Physics C students, if you've lasted this long in Panisi's class, you should feel real accomplished.
Starting magnetism, which is, while at sometimes frustrating, actually can be very simple.
During the magnetism unit, you'll be exposed to a lot of conventions and non-intuitive concepts. One of these is the right-hand rule. The right-hand rule basically tells you what direction the magnetic force will be as a result of a moving charge. It's actually really simple.
It consists of this. You point your index finger in the direction of the velocity of the charge, your middle finger in the direction of the magnetic field, and your thumb will point in the direction of the force. That's cool, right?
In physics, something you'll need to know is cross product. Cross product is basically a way to determine the direction of two vector quantities that interact. So usually in our case, we need it for magnetism. And in magnetism, a really important cross product that we need to know is V cross B. V is the velocity of a moving charge, and B is the magnetic field. And the V is in a direction. The V has a vector direction, and the B, the magnetic field, has a vector direction as well. So your V, the order matters. So your first vector that you're crossing always goes first in the following sequence that I'm going to describe. So usually. V is first, so V is in the direction of your index finger. Always use your right hand, okay? Unless it's a negative charge. With a negative charge, you'll need to use your left hand. Or you can just make it the opposite direction of what you get out with your right hand rule. Your V is your index finger. You're crossing it with B. B is your middle finger. So this is how we make it. V is the first vector, B is your second vector, and then your thumb will point in the direction of the force. That's the equation we're using. We're using F equals QV cross B. Okay. Now, in this case, if the V was going vertically and the B was to the left, then our thumb would point out of the page. Okay.
There are two important things you need to remember about magnetic forces. You can't have a magnetic force if the charge isn't moving. Simple as that. The magnetic field and the velocity of the charge create the largest force when they are perpendicular. If they are parallel, there is no force.
No force.
No.
Many multiple choice questions can be simplified if you remember these simple concepts. Magnetic forces are created by moving charges. If there's no moving charges, there's no magnetic force.
Another important concept in magnetism is the understanding that while you're going to delve into all the magnetism concepts, don't forget that electricity concept you just learned.
By this, we mean that many times on free response questions and multiple choice questions, you may need to flip back and forth between magnetism concepts.
A problem may have a magnetic field that creates a magnetic force on a charge, and you may need to indicate the direction of the electric field that would cause a force that negates that charge.
Let's look at a practice problem. Yeah. Can I have a McChicken, please?
Here's the AP Physics C Princeton Review Book. Here's a problem I want to talk about. On example 2, it says a particle of mass m and charge q is projected with velocity v in the plane of the page, and it's into a uniform B field. Now, it's asking how will the particle move? Now, what we know is that we have our right-hand rule. Our right-hand rule means that the V is pointed with our index finger, the middle finger points in the direction of the magnetic field, and then your thumb will point in the direction of the force. So let's look at the problem. The problem says that our V is pointing this way, right? And then our B is into the page. So it'll be like this. Our B will be into the page. So my middle finger points into the page. Then my thumb points in the direction of the force. That means that at this instance, we have a force that is pointed like this, right? Now, the force is pointed like that, so it'll cause a centripetal force. This charge will start moving in a circle. Why do I say this? Because as the force causes it to move to the left, that force will constantly. So this is the velocity. This is the cross product. The velocity is like this. As a result of the force, the charge will start turning left. As it's turning left, the B field is still into the page. So the force will continue to point towards the left side, the left of the velocity. So it'll constantly be turning, okay? It'll be turning, and it'll cause a centripetal force, as you can see right here. The solution says that since V is perpendicular to B, the magnetic force will blah blah blah, and it'll be direct. And if you can read right here, it says that F of B is always perpendicular to V. The particle will undergo uniform circular motion, and the force of FB will provide the magnetic force.
Physics.
Good night, little Jacob.
I'm good.
Hey man, what's up? Like, dude, you wanna play some PS3? Come on, you know, forget about physics. Who needs physics? No one needs physics. Oh my God, what you doing, man? Where you going?
Peace and quiet.
Make sure you complete all of your homework assignments. Do not skip any. If you come across any questions that you cannot understand, circle them and get help from someone else or Mr. Panisi. A lot of the quizzes have questions right off the homework, so those are easy points. If you make sure you master every homework question you come across, the tests and quizzes will be easy and the AP test will be an easy 5.
A study tip that I would suggest doing is to do practice problems. And as simple as it sounds, it actually does help a lot. I did it for every unit in the class, and I did fairly well on the tests and quizzes. And all you need to do is go on AP Central and find problems that relate to magnetism or any unit that you want to study. And doing so will refresh your memory on the concepts, will help you remember key formulas, and will give you the confidence you need to take on any test that comes your way.